Yeah. Next, coming to Brownian motion. Second parameter need to be considered. Theories of suspension is Brownian movement. Brownian movement of the particle prevents the sedimentation of the particles by keeping the dispersed material in random motion. Brownian movement depends upon the density of the dispersed phase and the density and viscosity of the dispersion medium. Here the kinetic bombardment of the particles by the molecules of the suspending medium will keep the particles suspending provided that their size is below critical radius. Here the Brownian motion, if the particle size is very less, when the density of the particle and viscosity of the medium are favorable, in such cases the particles will do Brownian motion. Brownian motion means continuous random motion of the particles is going to take place. If the particle density is low and viscosity of the medium also low, in such cases what will happen? The movement of the particle will takes place from here to here, and here any direction the particle can move. Okay, so if the particle is having less diameter and density as well as velocity, viscosity of the medium also less, in such cases movement of the particle will be easy to move. So Brownian motion will prevent the movement particle to settle down to the bottom of the container. Next one is interfacial properties of suspended particles. The large surface area of the particles that results from comminution is associated with the surface free energy that makes the system thermodynamically unstable. Here we have to consider, for preparing the suspension, we need to consider the particle size. Here the particle size should be very less to prevent the sedimentation of the particles to the bottom of the container. So while preparing the very fine particles, when we are decreasing the particle size to very fine particle size, this will leads to enormous increase in the surface area. If the surface area of the particle is increased, what will happen? The surface free energy of the system also get increases. Whenever the free energy of the system is increased, the system is prone to thermodynamically unstable system. So we need to consider whether the particle size is going beyond the limits or not. Okay, so for that purpose we have to control the comminution. Means what we can control? The rate of decrease of the particle size, means particle size reduction should be controlled. With how can we control the particle size reduction? For reducing the particle size, the material are subjected for grinding or milling process. So during that grinding and milling process, we have to adjust the parameters such that we should get this much sized particles at the end of the preparation. Okay, so we have to control the degree of particle size reduction, and the particles are highly energetic and tend to regroup in such a way that to decrease the total area and reduce the surface free energy. If the particle size is very much less, surface free energy is increasing. Whenever the surface free energy is increasing, the particle is unstable. To make the particle itself to stable, what the particle itself do? It will automatically regroup with the another type of particles. So what will happen? Again the cluster formation of the particles will take place. By that way they will increase their size on their own and they will regroup to form a cluster like structure, and surface free energy of the particles also reduces. The particles in liquid suspension therefore tend to flocculate, that is to form light fluffy conglomerates that are held together by weak van der Waals forces of attraction. That's what I explained now. Under certain conditions, in a compacted cake, for example, the particles may adhere by stronger forces to form what are termed as aggregates. Here in some conditions the particles may conglomerate together and they will form fluffy conglomerates. They are formed by weak and van der Waals forces of attraction. If the particles are aggregated with strong forces of attraction, this aggregation leads to hard cake formation, which leads to a stability problem. So the formation of any type of agglomerate, either floccules or aggregates, is taken as a measure of the system tendency to reach more thermodynamically stable state. So here we need to consider the surface free energy and interfacial tension between the solid particles and liquids. So this energy changes between the particles and the liquid medium should be considered to formulate a stable suspension with less internal energy. Next, coming to formulation of the suspension, here the suspension can be formulated if you take a flocculated suspension or a deflocculated suspension. Depending upon the type of the suspension we are going to prepare, the formulation aspects will be different. Here, if you are preparing a deflocculated suspension, just take the solid ingredients, suspending agents and liquid medium, we can prepare the deflocculated system very easily. But whenever we are going for a flocculated system, here flocculated systems are having different property, that is flocculation of the particles, means we need to include some flocculating agent. At the same time, as the floccules are forming, the floccules will cause change in the particle size, and at the same time whenever the particle size is increased, it leads to sedimentation, fast sedimentation. So we need to consider all the factors that are influencing the formulation of the suspension. Here the approaches may be commonly involved are use of structured vehicles, use of controlled flocculation, and combination of both the first and second method, means both the combination of use structured vehicle and controlled flocculation. By using these three methods we can prepare the suspensions. We will see one by one. Formulation of the suspension. Here finally, first you have to take the finely divided particles, and the particles are added to dispersion medium and wetting agent. Here if any wetting problem is there, then you have to add some small amount of wetting agent, and it leads to you will form a deflocculated suspension with the dispersed particles and liquid medium. Now this deflocculated system can be subjected for three different types of preparations. You can add a structured vehicle to this deflocculated system. Here whenever you add the structured vehicle, because of the presence of this structured vehicle in the deflocculated system, you will get a deflocculated suspension for external vehicle. Means here you can prepare the deflocculated suspension with a thick viscous preparation, means the sedimentation of the particles will be less, and at the same time you can maintain the some distance between the particles, and some due to the high viscosity of the preparation, the hard cake formation will be less. And the next one is you can go for flocculating agents also, addition of flocculating agents, controlled flocculation, you will get a flocculated suspension. And the third concept is flocculating agents as well as addition of some structured vehicle. Both the things are going to take place. By that way you can get a stable good emulsion. Here these are the aspects. Particles, you have to take the particles, add some wetting agent and the dispersion medium. If you take particles and the adding the wetting agent, it leads to some uniform dispersion of the flocculated particles in the dispersion medium. To this now you add a structured vehicle, in this case you will get a deflocculated suspension in a structured vehicle. Just to take the particles, add wetting agent and dispersion medium and triturate together, you will get a deflocculated suspension. Now whatever the suspension you have prepared, it is of simple suspension only. If you allow the suspension to stand up there, immediately the deflocculated particles are there, they will slowly settle down to the bottom of the container. If it is allowed for longer periods of time, the particles will get settled down and it leads to hard cake formation. What we have to do, we have to avoid the sedimentation fastly, and at the same time we have to avoid the hard cake formation. For that purpose, if you have added a structured vehicle is nothing but it is of highly viscous preparation which is made up of polymeric solutions, right? Now if you add any polymeric solution to this, the polymeric solution is having more viscosity, and the structured vehicle, because of the viscosity of the structured vehicle, the particles whatever they are dispersed in the medium will be present in the dispersion state only. They won't get settled down to the bottom of the container that much fastly, and the hard cake formation will be prevented with the case of structured vehicle addition. That is one concept. Second one is, to the deflocculated suspension add some flocculating agent. Flocculating agent means addition of some oppositely charged flocculating material. You will get a flocculated suspension. Floccules will be formed by the material excuse me. Floccules will be formed by the solid particles. Immediately it will lead to flocculated suspension. And fourth one is, third approach is adding a flocculating agent as well as a structured vehicle. You are adding, third case, flocculating agent you are adding. Due to the addition of flocculating agent, the suspended particles are forming floccules. Now floccules are having larger particle size. Larger particle size particles will get settled down very fastly. So what you are doing, you are adding additionally structured vehicle. The structured vehicle is meant for increasing the viscosity of the system. Viscosity of the system is increased. We are increasing the particle size as well as viscosity of the system. So what will happen? The increased viscosity of the system will reduce the moment of velocity of the particles, flocculated particles to the bottom of the container. Automatically what will happen? Though the particle size is increased, due to the increasing the viscosity of the medium, the floccules will not get settled down that much very fastly than the flocculated suspension. So finally, whatever the suspension you have prepared with the flocculating agent and structured vehicle, the hard cake formation is completely prevented, as well as the sedimentation process also will be controlled in case of the third condition. This is the in detailed step by step process. Okay. These are the different examples, structured vehicle examples. Non-ionic methyl cellulose, hydroxypropyl methyl cellulose, anionic sodium carboxy methyl cellulose, carbopol, clays and like bentonite can be used as structured vehicles. These are the flocculated system. Okay. You can see different step by step. In case of first, what is the first step? Dispersion medium you have to prepare. Dispersion of the solids. What is the dispersion? Take the water miscible or co-solvents or any type of dispersion you have to prepare. By adding a small amount of wetting agents, you will get the wetting agent and liquid medium and the particles in the dispersion manner. In the second step, you have to prepare the deflocculated suspension with structured vehicle. Here the structured vehicle is you are going to take any of the polymers, dissolve in the liquid medium, and you will get a colloidal protective colloidal suspension or the solution. Here these structured vehicles are having thixotropic behavior. Gel to sol, sol to gel conversion will be taking place. By that way, by use of these materials, you can improve the viscosity as well as stability of the system. Okay. Here in case of flocculated suspensions, flocculating agents like electrolytes, surfactants and polymers can be added with oppositely charged charge containing materials you have to take. This is the flocculation step we are going to control. Control flocculation means we have to add the specified quantities, not the excess quantity of flocculating agent can be added. At the same time, pH of the solution should be protected. Why? Because pH of changes can also change the some types of materials charges. So by that way, if you control the pH of the solution, you can control the floccule formation. Okay. These are the examples. Surfactants. If you add surfactant molecules, these are the particles. Anionic surfactant you have added. Particles are charged with positively charged and surfactants are having negative charge. So what will happen? The positive and negative charges of the particles will get attracted together and they will aggregate to form floccules. Examples: anionic surfactants are sodium lauryl sulfate, cationic surfactants are cetyl trimethyl ammonium bromide, non-ionic surfactants are twins. Polymeric materials: some polymers, they are having charges on their surfaces, and some polymers, they just carry the particles along with their extended strands. And hydrophilic, some protective colloids like hydrophilic polymers, they will form a sheath surrounding the floccules, and by that way they will improve the stability of the system. These are the flocculated suspension with structured vehicle. Just take the floccules and add the structured vehicle, that is hydroxypolymeric solution, to the floccules, flocculated suspension. You will get a suspension in the structured vehicle. And this is about preparation and formulation aspects of the suspensions. And coming to the this is about suspensions.